Thank you. We start this session with
Hello
a
to
video from
everyone,
Daniel.
and I hope you're enjoying day 3 of the Construction Blockchain Consortium 2023. My name is Daniel Hall, and I'm an assistant professor at TU Delft. Thank you very much for the invitation to be here as a keynote speaker today. Unfortunately, I wasn't able to travel to make the journey, but my collaborator, Dr. Jens Hunhovitz, was also attending, and I thought it made sense if we worked together to partner this keynote presentation. And that's really on the topic of integrated project delivery. This really goes back to a longer time period of about 10 years since I started my PhD work back in California, looking at this new phenomenon called integrated project delivery. And what we noticed is that this was a much more decentralized and collaborative project delivery environment when compared to traditional projects, which were much more centralized and used kind of more of a contractual hierarchy and a command and control approach. And we are trying to understand why is it that these decentralized mechanisms seems to help in the collaboration for projects. And what we found is that it helped a lot with understanding complexity and dealing with some of the challenges of complexity. And this is also represented in decentralized systems are much better at dealing with complexity. And this work continued and evolved over time in two distinct ways that have now come back together. The first is that we started to think about could collaborative project delivery models like IPD be considered a common pool resource scenario? And Jens is going to talk a little bit more about that. We began to understand and think about what it is about the commons and can projects be organized as a form of commons. At the same time, we also began to explore other ways of decentralized governance, especially through technology. And that's where blockchain came into play. We started to see that there were a lot of mechanisms that allowed for stakeholders to coordinate in a peer-to-peer way without relying on centralization. And this allowed us to open up ideas about the blockchain governance mechanisms. And when we put those two things together, we started to realize we had a new idea for project delivery, which is project delivery on the crypto commons. And that's where we are now. And Jens is going to explain a bit about the background behind this work and also present the new ideas about how we can decentralize project delivery and we can deliver projects on the crypto commons. So with that, thank you very much. Sorry I missed you this time, and I hope we get a chance to meet next time. And I will turn it over to Jens.
Thank you, Daniel. All right. So this work's also based on my last work package during my PhD, which I finished last year. So I hope I can bring you this topic closer instead of Daniel giving the presentation. So as Daniel mentioned, construction was repeatedly described as a complex system. If you look at the picture here, you can also see why this is actually quite a reasonable claim. We have many moving independent parts that need to coordinate, that are dependent on a lot of external factors, for example, traffic, supply chain that delivers products to the construction site. Then on the construction side, the different teams that need to coordinate amongst each other and are dependent on each other, or also external events like weather. So to manage complex system, decentralized bottom-up coordination is the most common way to manage these systems. There are several studies that looked at examples from nature, but also man-made systems like traffic or even wind turbine optimization. So complex systems are best managed through self-organization and bottom-up coordination. So predominant forms of organization in the construction industry are often top-down, and they often fail to deliver trusted coordination. We have often projects, especially large projects, that run over time and budget. So there is one approach that tries to tackle this, and this is called collaborative project delivery, which IPD is one way to set up a collaborative project delivery. So the idea is to use more decentralized governance approaches like shared decision-making, pooled resources that are commonly governed. So that's the background. So where does blockchain come in here now? So in this work, we put together a framework based on some observations we made. And the linking factor between blockchain and collaborative project delivery is common pool resource theory. So I want to show you each of these pieces of this conceptual framework so that you start to hopefully see the connections. So first, what is a common pool resource scenario? So common pool resources are by definition resources that are open to all. So very famous examples from nature are lakes where everyone can go and fish, or pastures where everyone can bring their cows to graze. So what happens if this is the case? So rational individuals, they act often in self-interested behavior and they take as many resources as they can. They want to optimize their own benefit. So what happens then if you don't have coordination? You deplete the resources. So, and then often the idea was then to regulate this and put top-down approaches in place to manage these resources, until Elinor Ostrom won the Nobel Prize for showing that with certain principles called the Ostrom principles, it's actually better and more efficient to manage these resources in a decentralized way and avoid this tragedy of the commons. So I'll stop here. There is a common pool resource theory is a big topic on its own. So IPD is, as Daniel mentioned, it's actually Daniel's work from his PhD that conceptualized IPD as a common pool resource scenario. So in some ways, projects have similarities with common pool resources. You have a shared resource pool like a budget or schedule, and you need to coordinate the depletion of these resources among these actors. And if you don't coordinate well, you have the tragedy of the project, you run over budget or over schedule, because everyone tries to take as much of these resources as possible, because they're finite. So one approach to manage this is like through IPD, where you pool together these resources, so you have a common pool of resources, and you set governance structures in place to manage these. So one incentive mechanism of IPD is, for example, shared risk reward. So instead of competing for resources, you need to coordinate the resources throughout the project, and only at the end of the project, if the overall project makes a profit, you share it among all companies. If you lose, you share the risk. And this kind of is very a successful approach. It doesn't get applied too often, but when it gets applied, it's often quite successful. The final piece of this conceptualization is blockchain as a commons. So it's very interesting that blockchains themselves can be seen as a common pool resource scenario. So blockchains share similarities of free and open source software. So, for example, Wikipedia is an example of a free and open source software. And these open source softwares have often problems of free riding. So for example, in Wikipedia, everyone reads and benefits from the resource, but no one really wants to write the articles. And with blockchains are actually very expensive systems to operate, right? They have all these distributed databases. You have the consensus mechanisms that you need to keep running and add transactions. So the interesting part is, how did blockchain solve this common pool resource problem? And the answer is cryptoeconomics. So there are systems, mechanisms in place that if you contribute to the system and you don't cheat, you benefit. If you cheat, you lose. So there is actually human incentives in place. For example, with Bitcoin, you earn Bitcoin if you mine and don't actually be malicious. So the interesting thing is that you now can leverage some of these mechanisms that are proven to work quite well for blockchain as a common pool resource scenario to scale common pool resource scenarios. Because that's one limitation of common pool resource scenarios, that coordination on bottom-up coordination of these scenarios is actually quite hard on a larger scale, because you need a lot of coordination and feedback loops. So how do we leverage this? I mean, the answer is smart contracts and tokens. I think I can go fast here because you all know these concepts. And you can build then applications and mechanisms using these tools to encode the Ostrom principles, so these principles that are proposed to manage common pool resource scenarios. So what are these mechanisms? That was our question. So we started to research and we identified 14 mechanisms proposed by different literature that try to encode these Ostrom principles. I mean, you cannot read this; it's not so relevant at this time. If you're interested in these, you can also read them. I give you some more insights in a minute. So this is the same graph, slightly simplified, but you still cannot read it. And then we actually thought, okay, we have these mechanisms. How can we apply them to like IPD? And we didn't have to think of all these mechanisms ourselves. The interesting thing is that a lot of the mechanisms, and some of them were also talked about during this conference, are actually in line with what the Ostrom principles propose. So there are 22 applications that we identified that align with these proposed mechanisms. So some obvious ones, the cornerstone of like Ostrom principle conpool resource is like identity identification. And we all know blockchain is actually really good at that. Each address is unique and can be proven, and the signatures can prove ownership and that you actually are who you are. The second very important cornerstone is the tokenization of resource pools. And we also heard about project bank accounts, ideas of how blockchain can manage these. So tokenizing resources actually makes them transparent and manageable in a different way than we have nowadays. A third really important cornerstone is the monitoring and the reaction. That's actually Ostrom principle number 1, 2, 3, 4, I think. Yeah. So blockchain makes everything very transparent. So what this enables is fast feedback loops, and Professor Brilhocki's presentation reminded me again of these fast feedback loops. I think that might be an interesting connection to digital twins. For governance of like decentralized fast bottom-up coordination, you need fast feedback loop of information, and for that you need transparent and trusted information. So if you have all these segments in place, you can establish coordination mechanisms. And there are many examples. I don't have time to go through all of them. But for example, how can you appropriate the resource? How can you use the resources and who can use them? Is it a shared risk reward contract, or is it one or multiple resource pools, right? We heard about marketplaces like tendering, for example. It's also part of transparent procurement that is needed for this coordination. Or like dispute resolution systems is also part of the common rules of the Ostrom principles. Tokens for penalizing people if they don't behave, for example. If they stake tokens and they can lose value, it's actually a way to penalize bad behavior, maybe in a project. Or even just having transparency in like actions is enough for social sanctions. You don't even need tokens, maybe. So these are all ideas that then link together. And overall, I think the framework involves 87 resources. A lot of the papers are also written by you. So it's basically an overarching framework how these things might go together. So how would that work? I mean, we imagine it would be actually very similar to how IPD works nowadays. You start with the initiators, you define the blockchain governance system instead of just the IPD system. You fund and secure the resource pools, and you register contributors willing to participate. If it's on the blockchain, this could also be machine agents, for example, not just humans, which is one difference maybe. And then you execute the project according to this governance system. Ideally, it can also adjust a bit to the process, so it shouldn't be too fixed, of course. Then your project closes and you distribute the rewards. So this is actually it's actually a system perspective. So we try to identify which of these applications are dependent on others. And there are clear applications that are the prerequisite for others. So the system can scale basically from individual applications, for example, blockchain only for tendering, to like a complete system where you have blockchain for project coordination. So it's a system perspective of how different applications might tie together to deliver a project. So what does this mean? I think this is not part of the paper I just presented. It's a different book chapter. If you're interested, here's the QR code. It's called The Promise of Blockchain for the Construction Industry. It's one of these, who said that in the beginning? There was one presentation that said there are too many book chapters about the promise of blockchain. I also wrote one. And it's one of the figures in there is this one. And I think it actually is interesting to discuss this in this conference, because when we look at the industry structure, we can have centralized versus decentralized. And the predominant system is mostly decentralized. So we have a lot of actors that need to work together in a very decentralized way. And economic theory then suggests the economic system needs to align with the structure of the system. So top-down approaches are good for centralized approaches, bottom-up approaches for decentralized approaches. And the current situation is that we have top-down approaches for a decentralized system. So one way to solve this would be to shift the industry structure towards a more central system, so reduce complexity. And I think we heard a lot about one approach that does this. It's MIC, right? So what you try to do is you start to integrate the supply chain, reduce complexity of the product. So it's a simpler product. You have less dependencies, integrated supply chain, top-down approaches work quite well. You have a more efficient system. But we argue that actually it's also a possibility to shift the governance system towards bottom-up approaches. And we think that actually blockchain, like IPD does that already in some way, and blockchain is actually a way to scale this towards a new level. So the question is then, how do you build these bottom-up approaches? I mean, we identified some of the mechanisms, some of the application. We don't have an answer yet how this would all work together, but we think it's actually a very interesting vision how blockchain aligns with some of the industry structure we have and actually uses the decentralized industry structure as a strength. Instead of just always saying, oh, we are fragmented, we're decentralized, we need to shift towards a simpler system, we can just shift the governance towards a system that is actually better able to deal with this system. Because decentralization also has a lot of, and you know this, you're working in blockchain, it also has a lot of benefits, right? It's usually more resilient, for example, right, than a central system. So common pool resource theory is a very interesting economic lens related to crypto economics and decentralization. What we did is we tried to conceptualize what is this decentralized project delivery, what applications would be included, what do we see right now. And when thinking about this, you can see potential to improve current project delivery system, but maybe also think about, okay, what's the next generation of project delivery systems? Now we have these technologies available. So, of course, I'm aware that this is a very research-based presentation. It's a concept. Of course, there are many challenges to overcome if you want to implement something like this. We heard many of these during the previous talks, so we don't need to repeat them. But I hope you found this interesting. If you want to read more about this, these are the sources that are published for now that talk about this. We hope that the paper with the figures I showed you today will be published soon. Thank you for your attention.